Right then, so basically, indices, otherwise known as powers, um, let's just recap what we know about them already. So if I wrote 3 and then a little 2 up there, that we can say that's 3 squared, or we can say 3 to the power of 2. Okay, now we know that that means 3 times 3. And we know that 3 cubed is 3 times 3 times 3. So we can think of this as being how many times we multiply 3 by itself. So what about if I did something like 3 to the power of 1? Well, actually, that just, we can think if we count how many 3's we've got here, I guess we just have one of them, right? So let's put that one up here. And so as we can see, when we go down 1, 2, 3, as we increase the power here, let's highlight this. So this is the power. Let's use a bit of terminology here. We can call that the power on, yeah, and what I'll do is I'll also colour this one here, and we can call this the base. Okay, so let's learn a bit of terminology. This is the power. Actually, yeah, I'll copy this one here, down here. I will say this is the power, and this is the base. Now let's notice what happens as we go down here. As we increase the power, we're multiplying. When we increase the power by 1, we multiply it by the base. The base gets multiplied by itself. So, and as we reduce the power, we're decreasing it. So as we go from here to here, we are timesing it by it's timesing it by 3, but that's only because the base is 3, right? Whereas if I went upwards and I reduced it, I'm going to divide it by the base by 3. Okay. So if we can now use that to imagine what would 3 to the power of 0 be. Well, I'm going to just keep dividing it by 3. 3 divided by 3 is 1. So, and in fact, that's going to be the same, right? So whatever the base is, if I divide the base by itself, it's 1. So in actual fact, we could say that x, where x could be any number, x to the power of 0 is always going to be equal to 1. So that could be our first kind of rule, right? So let's put that in a little square, and we'll group that, and we're happy with that one now. That's our first rule that we're going to introduce ourselves to. Now let's have a look at some of these other ones. What about if I did 3 cubed multiplied by 3 squared? Okay, so 3 cubed multiplied by 3 squared. Well, that's 3 cubed right there. I'm going to unhighlight these bits for the moment because I want to highlight them in a different way. So I want to just highlight all. I'll use a different color though. All of that. And I think, yeah, and then highlight all of that. So that's my 3 cubed. I'm going to multiply that by 3 squared. And that's 3 squared, right? Now you might be able to see what's going to happen here. Let's colour that in blue. And I'll colour that in blue. If this is 3 squared and this is 3 cubed, or 3 to the power of 3, then we now have 1, 2, 3, 4, 5. So that must be 3 to the power of 5. And with a little bit of experimentation and playing around with this, we can come up with a rule that essentially x to the power of a multiplied by x to the power of b is equal to x to the power of a plus b. Okay, so that's our second rule. Okay, because I added 3 and 2 and I got 5, right? So that's our second rule. We're going to be applying this. It's quite good to be able to sort of follow along why these, to understand what these rules are. That's harder than actually applying them, but understanding them is quite a good idea all the same. So I think I'm using quite a lot of space here, probably more than I need to. So I'm going to take all these here. I'm just going to shrink them a little bit. And we'll also increase the thickness a bit. Okay, that doesn't work. Okay, so now let's have a look at another way of doing this. So let's say we've got 3 to the power 5, and we're going to divide it. 3 to the power 5, we're going to divide by 3 squared. Well, we know that 3 to the power 5 is 3 times 3 times 3 times 3 times 3, and 3 squared is just 3 times 3. Now, we've done this before many times. We know that we can just cancel them out. So we know that I can just take this, and let's do it like this. Cross that one out with that, and cross that one out with that. I end up with 3 to the power of 3. In other words, when I take any number and it's to the power of another number, and I divide it by the same base, right, to the power of a different number, I always get x to the power of a minus b. And here we did 5 minus 2, which gives me 3. Okay, maybe what I want to do is color in the x. Again, remember that's the base. Okay, that's our base. These won't work if we change the base. If I did x to the power of a divided by y to the power of b, I won't really be able to do much else. I won't be able to simplify it any further. So these are some bases here. So this is our third rule. And we need to understand and be familiar with these rules before we understand the harder rules, which we're going to get to minus numbers and fractions. The fractions are the hardest ones, but we're going to work our way up to that. So we've got, if we get any number and raise it to the power of 0, it's going to be 1. I showed that with this division idea. If we take a number and multiply it, and it's to the power of something, and multiply it by another thing to the power of something, it's equal to x to the power of those two powers added together. And when we divide, we minus them. Okay. Okay, that's fine. I think I'm just going to just lock that. And hopefully I can now do this. Okay, that'll do. All right. So what's next? Now, what about minus powers? Well, if we take the third rule I've done here, and we experiment with some other examples, then if I did, for example, 3, I'm always doing 3 for some reason, but 3 squared divided by 3 to the power of 5, that apparently should be equal to 3 to the power of 2 minus 5, according to this rule here, which would give me 3 to the power of negative 3. Now, if we look at what that would be in terms of these powers here, in terms of what we know they mean, it's going to be 3 times 3 divided by 3 times 3 times 3 times 3 times 3.
Cutting off a bit.
Ah. Okay, so basically we have, so using this rule here, then 3, then basically if I take 3 squared and I divide it by 3 to the power of 5, then it should be equal to 3 to the power of 2 minus 5, which should give me 3 to the power of negative 3. So in other words, that should be 3 to the power of negative 3. Now we know that also I can cancel that and cancel that, which gives me just 1 at the top, and at the bottom 3 to the power of 3. So therefore 1 over 3 to the power of 3 is equal to 3 to the power of negative 3. So what this is kind of showing is that if I take any number here, I still want to make a thicker pen. If I take any number and I raise it to the power of negative a, that's the same as 1 over the same base to the power of a. Okay, that's what this is kind of showing. So this is our fourth rule. Let's highlight the base. Well, okay, I'll highlight the power first then. And the base. Right. So this is our fourth rule. Still keep zooming out, don't I? I want to. Okay, there's my explanation for that one. Okay, next we're going to try to understand. So this is the. I think we've just got the fraction one left to understand. So let's imagine. I'm going to zoom in a bit more. And let's use this one again. Now, I know that x to the power of, well, let's use numbers. Let's do 4. So I know that 4 to the power of 4 to the power of 1 should be the same as 4 to the power of a half plus a half. Well, it is, isn't it? Clearly, 1 a half plus a half is 1, right? So, and we know that when we do that, according to this rule on the right here, that is the same as saying 4 to the power of a half multiplied by 4 to the power of a half. That's just using this second rule here. So essentially we've got this first half can be the A and the second half could be the B, right? So now, that what we're saying then is that 4 to the power of a half multiplied by itself or squared is the same as 4 to the power of 1, or in other words, just 4. So to find out what 4 to the half means, what we can do now is we can kind of make this the subject by square rooting both sides, and it would cancel out this square here. So if this is true, then I could say that 4 to the power of a half is equal to the square root of 4. So in other words, what we can say is that x to the power of 1 over a is equal to the 8th root of x. Now that one's a weird one to understand, but we'll do a bit of practice and maybe I can try to explain it a little bit more clearly. But that's I'll just include that bit for the video, and then we're going to be trying to apply these rules as well now. So I'll just stop the video there.